Hello and welcome to this second algorithm selection and development lecture in this course Master in Artificial Intelligence. So in this lecture also we will continue to talk about how to research, select and develop appropriate machine learning and deep learning algorithms and architectures based on the problem at hand and the available data. So, after having understood the problem and defined the problem, as you see here, the next step is to determine. So, the question is how to determine the type of output and the evaluation matrices. Any thoughts? See, determining the type of output in between, for example, classification, regression, clustering, and selecting the appropriate evaluation metrics, you know, depends on the nature of the problem that you have, the available data that you have, and what outcome do you want. Now, how can you determine the type of output and select suitable evaluation metrics? Let's take a look at that. So first, we need to understand the classification itself. Now, what does the classification task involve? The classification task involve predicting discrete class labels, discrete labels as we will explain you. Discrete meaning not continuous, they're separate buckets and or categories for the input data. So you have input data and you need to predict what class or what category do they belong to. And the examples that I was talking about include spam detection, whether the particular mail or message is a spam or not a spam, two categories. Sentiment analysis, whether the sentiment expressed by the comment is positive, negative, or neutral, three categories. And image classification. Image classification could be any numbers, for example, cat, dog, and bird. Now, how do you find whether the problem is a classification task? So to determine that, what you need to do is to check if the target variable, that the variable that you want to classify, consists of categorical labels or classes. And we will talk about this later on in a lot more detail. But that's the way and if the answer is yes, then it's a classification task. The evaluation matrices, what are the evaluation metrics for classification? The first one is accuracy. And accuracy is percentage of correctly classified instances out of all instances. If you classified 100 data, what percentage of that did you classify correctly? Second is, so that's the accuracy. The second is precision, recall, and F1 score. These are metrics to evaluate the performance of binary or multi-class classification model, and what these are we will talk about in the remaining part of this lecture. And the third one is area under receiver operating characteristic, what is called ROC AUC curve, and this measures the ability of model to distinguish between classes correctly, right? And we will explain what that is. And finally, the key to thing is what is called a confusion matrix that provides a breakdown of correct and incorrect predictions for each class. So let's take a look at each of these in detail. So as we were mentioning, accuracy is that if you predicted 100 times, what percentage of time did you get it right? Are you till what percentage of time did you hit the target, the bullseye? And that's what is accuracy. Now precision is different. Precision is about hitting consistently one area, one point closely. It may not be the right one. You will be precise, but you may not be accurate. So that is precision, and we will define mathematically what precision is as we go forward. The recall is about, how many, so recall is about how many relevant items were retrieved. Now let's understand this relevant items in this matrix on the left hand side. So you have this whole set of data that consists of false negatives, true negatives, false positives, and true negatives. Now, true positives and false positive are from the data that you have retrieved. that you are predicting. Now, out of that, you will be right. So those are true positive, and there are false positive. Now, so if you look at the precision is how many retrieve items were relevant. That is how many did you totally receive. If you're the total elements that is predicted or unpredicted, how many retrieved items were relevant of the retrieved items. True positives divided by total positives and false positive is what is precision. Now it doesn't need to be accurate. The recall is how many relevant items were retrieved. If your universe consisted of false negatives and true positives, so the percentage of your true positives divided by total of true positives and false negatives is your recall. So that's how. So what percentage of the right items were you able to get is what is recall all about. Now, the F1 score is a evaluation matrix that combines two matrices, precise, precision, and recall into single matrix by taking their harmonic mean. And in simple terms, the F1 score is the weighted average score mean of precision and recall as you see this formula, right? So that's what F1 score is. Then area under receiver operating characteristic curve. Let's take a look at that. Uh, the area under receiver characteristic curve is you see there are four curves that you see here: black, red, greenish, blue, and the pink. So it is under this curve that is what is called the area under the curve. Now, if you're a perfect classifier, you have all the area under that, and you have predicted everything. So it's a plot of a true positive rate and a false positive rate. So if you are a true positive rate, you are predicting 100% right, there are no false positive. And if you are on the other side, if you are 50-50 between true positive and false positive, 1:1 ratio, then it is a poor performance. Anything between the two is between good and excellent. So the area under receiver operating curve is a perfect classifier will have AUC equal to 1. A poor classifier will have AUC of 0.5. A good classifier will have AUC greater than 0.5, and the excellent will be once it reaches the 1 level. And the definitions of the true and false positives as you see here are, so if you have acquired class that you have retrieved, and out of that you could have false positives, true positives and false negatives, whereas what you have and the true class is true and false. So the true positive rate is TPR. True positive rate is how many positives did you get between the true positives and false negatives, the first column. So true class. So what was true and how many were you able to retrieve? So true positive rate. Well, false positive rate is false positive divided by false positive plus true negatives. And accuracy is, as we saw that earlier, true positives plus TN, TP, true positives and true negatives, both you got right, and divided by the total number of observations that you have. So that's what is ROC AUC curve. So the confusion matrix is pivotal to know. It contains everything that we have talked about, as all the matrices are derived from it, whether be precision, recall, F1 score or accuracy. And it kind of it's a comprehensive representation of the various terms. The true positives to true negatives, which determine accuracy, whereas false positive and false negative. So that's what you can take a look at it at your leisure. So having looked at all this data of classification, the definitions and how to measure definitions and what are the evaluation, we will now look at regression in second type of data, second type of outcome that may you want, which is called regression in the next lecture. So thank you so much for watching this second algorithm selection and development lecture. I hope you're continuing to learn new things, continuing to enjoy. And I do look forward to seeing you again in the next lecture. please feel free to message me if you have any questions, and please do download the PDF file and specifically take a look at it in detail, study the confusion metrics in detail and correlate it to the concepts that we had talked about, the various evaluation matrices that we had talked about.